students, welcome to the channel Notion of Mathematics. In today's video, we will be discussing that what is the meaning of symmetric matrix and skew-symmetric matrix. So for this purpose, two definitions I have written. This first is related to the symmetric matrix. So we will say that a matrix is symmetric matrix if its transpose is equal to the original matrix. And when any matrix is said to be the skew-symmetric matrix, if the transpose of the original matrix is equal to minus A, right? So firstly, we will see the examples of symmetric matrix, and then we will validate the examples of skew-symmetric matrix. So let us now just go to the examples of symmetric matrix. So for this purpose, I have taken this A1 matrix. So matrix A1 is here provided as A, H and B, right? I want to prove that, I want to check that, I want to verify that this particular matrix is symmetric matrix or not. So as per the definition of symmetric matrix, it must be A1 transpose is equal to the original matrix. So if this is the matrix A1, I will be taking the transpose of this matrix, and transpose of any matrix means what? Whatever is the row that will be transformed into column, and whatever is the column that will be transformed into row, right? It means row will be column and column will be row. Column will be row. So this first row will be first column, that is AH, and the second row will be the second column, that is HB. And if you see that this is the original matrix, this is the original matrix that is equal to A1. So this particular condition is validated here, so we will claim that it is a symmetric matrix. Now the same definition I will apply for the matrix A2 as well. So matrix A2 is what? Matrix A2 is here given like A, H, G, H, B, F, and G, F, and C. It is a 3 by 3 matrix. I want to validate like this particular matrix is symmetric matrix or not. So what I will be doing here, I will be taking here A2, this matrix A2, its transpose. So its transpose means what? Whatever is the first row, that is first column, that is A, H, G. Whatever is the second row, that is second column, that is H, B, F, and whatever is the third row, that is third column, that is G, F, and C, right? And if you see that this particular is the original matrix, and that is the matrix A2. So A2 transpose is equal to original matrix. So again we will claim that this particular matrix is symmetric matrix. So this matrix is also symmetric matrix, this matrix is also the symmetric matrix. Now it's time to validate these two examples for skew-symmetric matrix. So firstly, I will be taking here matrix A3. So matrix A3 is what here? Matrix A3 is here 0, A, minus A, and 0. Let me take the transpose of this matrix. We will take the transpose of this matrix. So this will be what? First row will be first column, so that is 0A, and the second row will be the second column, that is minus A, 0. So A3 transpose is here, but I need here minus A3 as well. So what will be the minus A3? Let me multiply with the minus sign in this particular equation. So it will be 0, it will be minus A, and it will be A, and it will be 0. So you can see that this particular matrix is equal to, this is A3, this particular matrix, I mean to say this particular matrix is A3. It is the original matrix. I mean to say this particular matrix A3 transpose is here 0, minus A, and 0, and this particular matrix minus A3 is this one. So this matrix and this matrix, these are equal. So what we can claim here, A3 transpose is equal to minus A3. So this is as per the definition of skew-symmetric matrix. It is as per the definition of skew-symmetric matrix. So we'll claim that this is skew-symmetric matrix. Now if I will go for next example, that is related to A4, So what is the matrix A4 here? Let me write it here again. It is 0, A, B, it is minus A, 0, and C. It is minus B, minus C, and 0. So I will take the transpose of this particular matrix. So it will be what? First row will be the first column, that is 0, A, B. Second row will be the second column, that is minus A, 0, C, and the third row will become the third column, that will be minus B, minus C, and 0. Apart from it, what I need minus A4. I need minus A4. So if I will multiply this matrix with minus 1, so it will be 0, minus A, minus B. It is A, 0 and minus C. It is B, C and 0. So if you see this particular matrix, A4 transpose, and if you see this particular matrix, minus A4, so these two are equal. These two are equal. That is A4 transpose is equal to minus A4. So as per the condition of a skew-symmetric matrix, we will claim that this is a skew-symmetric matrix. So in this particular video, we just learned that how we can check, how we can verify that any given matrix is any given matrix is symmetric matrix or not, right? And in the same way, we can just validate that any given matrix is skew-symmetric matrix or not. So I hope this will be quite useful video for all of you. Thank you so much for watching this video.